you've got to think about how do you actually take your science to society, to policy, to industry, and I must say, I've already seen evidences of that. So my interest in science started off with cells. All of us are made out of trillions of cells, but we all start with a single cell. And this single cell divides. When it's old, it dies, and then you have new cells, right? But there are certain types of cells that happen to divide faster. They then try to eat and try to take a lot of resources within your body by creating blood vessels, evading the immune system. But ultimately, it also then becomes a parasite. It then invades into other parts of the body. And what disease is that? Cancer. Very good. And those are cancer cells that are dividing very rapidly. And that's the picture on the side. And we know that the basis of all cancers is genetic. Not all cancers are inherited. Only about 5% of us have got genetic predisposition to cancers. But 95% of cancers are because of the environment and what we have mutations into our DNA. So I know that we have got mixed group of people, but majority of you are in biotech and biomedical science. So you all know the central dogma of science, which is basically your DNA gets translated to RNA, and not all your RNA, but most of your RNA, the ones that are coding, will then code for proteins. And these proteins make up all the different recipes that make you into the beautiful dish that you are. But just like your typing, just like stuff that you do, every time the cell divides, it exposes its DNA. And during this cell division, if you are in an environment where you're exposed to various different types of mutagens, those are what we call as agents that cause mutations. And when agents that cause mutations cause cancer, you call them carcinogens. And these agents ultimately increase the risk of your cells transforming into your cancer. And so all of you know your cell cycle. What are the 4 major states of cell cycle? The G1, the S phase, the synthesis phase, then the second gap, G2, and then mitosis. Very good. You guys are so good. REC, you do such a good job with your students. And in cancer, when we talk about the 25,000 genes that is in every single cell, we have 3 types of groups of genes that ultimately cause cancer to accelerate. And so imagine your cell like a car, and basically you have these 3 genes that keeps this car functioning and actually performing its task. And so the first one is the oncogenes, and those are your accelerators. And these proto-oncogenes are really important. Without them, your cells can't grow. And then you have the brakes, and that's your tumor suppressor genes. So you probably have heard of P53, PRB, and many other tumor suppressors. They act as the brake to say, hey, don't move yet. We need to make sure whether everything is working. And then you need those mechanics, and those are your DNA repair genes. And you probably have heard of BRCA1 and BRCA2. That every time the cell goes through division, basically these DNA repair genes repair and make sure the information is correct. A common misconception in cancer is, you probably have heard this, right? When someone tells you, oh, this person was very stressed, and then they got cancer, right? They were working very hard for the last 6 months, and then, this thing happened to them. But actually, if there's one thing I want you to take away from today, is to understand that actually for most cases, cancer is a very long time dependent process. In fact, majority of cancers take basically between 15 to 30 years before it manifests as a cancer from the first time a cell acquires a mutation. And every cancer that gets diagnosed usually carries between a minimum of 10 mutations to thousands of mutations. So this is what happens. It's a step and a progress. A cell goes, oops, I got a mutation. Most of the time, it doesn't do much. It continues to divide. And then, oops, a second mutation. Remember, the cell is dividing, and the cell cycle has got errors in it. And then it acquires more mutations, and then that snowball effect happens, and then you have tumor invasion. Usually by the time it reaches the third stage, you usually get a diagnosis that you have cancer. So my work has focused on bladder cancer, but it's no different than any other cancers. In fact, today, we are understanding that the source of where your tumor comes from, the tissue, is not as important as actually the combination of genetic mutations. That certain types of bladder cancer behaves like a breast cancer or certain skin cancer because of the genetic mutations that it has already occurred. And so my interest is in bladder cancer. Why I like bladder cancer? Because it's a beautiful organ, because you can see how the cancer actually progresses. And more importantly, it has got one of the biggest or highest recurrence rates. So patients who get diagnosed, even though they don't die, every 3 months they must go to the hospital to test and see whether the cancer has come back. And for those who already have got muscle invasive, now the cancer has gone through the bladder wall, the risk of invasion becomes way higher. And so it's really quite a beautiful, basically a model to understand how do cancer cells acquire different mutations, and how can you be able to understand and maybe address so that we can stop the cancer from happening much earlier. So my body of work that I'm going to share with you today is biomarker research. And I know I checked your academics at REC have been publishing quite a number of work. And these biomarkers can be for any types of diseases. A biomarker helps to tell us whether you have the disease, right? That's a diagnostic disease. You will have the disease. That's a predictive biomarker. But a good biomarker can also tell you what kind of therapy I can use so that I get the better chance of recovering or surviving. And that's a therapeutic biomarker. The work that I'm going to share with you is a work that has been built because of genomics, right? And I know that the Indian government has also been spending quite a bit, and today one of your speakers earlier did talk about the work that he has done and his company is doing. And the work we try to do and have done is about how can we predict which types of cancers can recur quickly, which kind of cancers can actually invade. And through the use of multiple genes, rather than looking at one gene, we have identified a specific pathway called the DNA repair. Remember that mechanic in that car, the 3 groups of genes? What are the 3 groups of genes? The first one is the accelerator. What are they called? Oncogenes or proto-oncogenes. Very good. What about the brakes? What are they called? Tumor suppressor genes. Fantastic. And what are the mechanics called? The DNA repair genes. Fantastic. Okay, you're not sleeping yet. Very good. So we found that the DNA repair genes basically are dysregulated. Even though there are no mutations, the RNA, the gene expression, has actually changed. And one particular proto-oncogene that had never been reported before in bladder cancer was called aurora kinase A. And aurora kinase A plays a role in actually ensuring the cell to basically move from G2 to M and M into the next phase of G1. And we found that certain groups of bladder cancer have an increased amount of DNA copies. So most of us have 2 copies for each of our genes. But in the case of some cancers, they actually have more copies of aurora A. So more copies of DNA means more copies of RNA, and more copies of RNA will mean more copies of protein, right? And that's one way a proto-oncogene becomes an oncogene. And this was shown through immunohistochemistry that in some cancers, while the cancer is only in the cytoplasm, that's the brown color, and the black is where the nucleus is. But you'll notice in some cancers, the nucleus is really dark. And that's because aurora kinase has been translocated into the nucleus and now is functioning very differently. And what does it do? When we overexpress aurora kinase, this is a normal cell with the spindles, very normal, bipolar. But if you overexpress aurora kinase, suddenly the cell has lost its ability to divide normally. There are spindle defects. And with this, you obviously have more accumulation of mutations and greater genomic instability. What was interesting is we also found that when aurora kinase is up, when the proto-oncogene is overexpressed, you had a reduction in the DNA repair genes, not mutated, like breast cancer, BRCA1 and BRCA2. You probably have heard about the Angelina Jolie effect. Now, in this case, basically, there's no mutations, but the gene level expression is still very low. So we got very excited because actually there are multiple drugs that actually target aurora kinase. So we thought that with basically patients that can be treated, why not? Maybe they will be better treated with aurora kinase inhibitors. Unfortunately, this is science. To date, there is still no good drug that can treat aurora kinase because it's too toxic. The drug kills the people before the cancer even kills it. And so, thus far, we've not been able to translate this potentially important discovery into therapy. So that's one big challenge for you. Maybe amongst you, some engineers and technologists can think about, can I look for this drug that perhaps can basically underexpress aurora kinase? Another important thing, right, in genetic research is we are all understanding now when we read textbook or when we go onto Scopus or OMIM, right, what is the function of a particular gene? And usually they will say, this gene functions in this way. This is how the gene works. An important thing that I need you all to understand is actually genes are like humans, right? And if that's something to be learned, is that how you behave at home and how you behave in college or how you behave when your lecturers are not watching you are going to be very different, right? And so that's exactly what genes we are understanding now. When a particular gene is expressed with other genes, it behaves differently. It functions differently. And the next story I'm going to talk to you about is this AIMP3 story, which is really exciting. AIMP3 is an amino acyl tRNA transferase enzyme, synthetase enzyme. What is that? It is just a carrier during protein translation. You wouldn't expect it to be of any significance in cancer. But we found that actually many cancers, about 52% of cancers, actually have got a loss or low level of expression of this particular protein. So you'll notice normal, it's really dark brown, so that protein is there. But in cancer cells, almost not existent. And we were able to show that even though the normal function of AIMP3 is to just help to carry an amino acid during translation, it also plays an extremely important role in the triggering of your DNA damage response. It doesn't repair the DNA, but it's important in ensuring the DNA repair genes actually function. And it's actually quite upstream when there's a damage. And so when my postdoc did these experiments, when he actually knocked down the expression of AIMP, he found that basically that the cells actually now responded less to radiation. You can see in the dark gray, when it's knocked down, when AIMP3 levels are low, you have a higher survivability against radiation. So we ask ourselves, what could we use this information with? And that is because in bladder cancer, patients where the cancer hasn't spread out, hasn't metastasized, doctors have got only two options. Do I keep the bladder and just maybe use radiotherapy and surgery, or do I remove the whole bladder? And the work that we have shown basically shows that AIMP3 is a good marker that cancers that have low levels of AIMP3, we actually tell the doctor, you might as well remove the bladder because these patients will not respond to radiotherapy. And if you treat that patient for 3 months or 6 months with radiotherapy, most likely the cancer will spread and then it becomes too late. So this is really an exciting piece of work. Unlike aurora kinase, has got translation. And why this is important is because ultimately the reason why we do science, The reason all of you are doing such important projects, and I was so excited to go into your titanium gym to hear your different projects, is because you want to make sure your knowledge translates to action. And in cancer research, a lot of us are always thinking about novel therapeutics. And so there are more and more drug targets that are out there. There are now immunotherapies, there are molecular inhibitors, and various different targets that are improving the outcomes of individuals. But we also know that cost is a big issue. In many instances, it doesn't matter for 99.99999% of individuals. They will not afford the drugs that you are creating in the lab. In fact, I must congratulate India, because I think India is one of the only countries who have said that the responsibility is to the citizens when it comes to cost, and they have been actually quite aggressively working with the pharmaceutical industries to actually overcome this. So the final example that I want to show you is about the work that we are now doing over the last 8 years on using viruses. Because we believe that what is the organism, or what's the thing that divides faster, more aggressive than cancer, and that is the virus. And so there are multiple viruses that have been found to selectively kill cancer cells very effectively. And one example is the Newcastle disease virus that I know also exists in India, but it's usually a problem because it kills chickens. But the good thing is that it doesn't kill humans. But it might give you an eye sore, it might give you some mild flu symptoms, but ultimately it's safe to normal cells. But work that was done since 2007, not by me but by other researchers, identified that actually this Newcastle disease virus has a 10,000 times greater selectivity to cancer cells than in human cells. And so we asked ourselves, using genetic engineering, and I know you have a great genetic engineering and recombinant program at REC, is how can we use the virus, but not use the native virus, but maybe create a recombinant virus where the virus not only gets produced, we also introduce certain types of interleukins, because we know that stimulatory immune response are important. And so we tested out to see whether mice that had cancer, when we inject them with this recombinant virus, do we actually reduce the number of cancer cells? And this, without going into great detail, the answer is yes. And the paper is also available if you were interested. And while it did not remove the tumors completely, you can see the RAF-IL-12, that's the recombinant virus, the tumor mass is a lot smaller compared to the negative control or even the normal virus that you actually put in. Nevertheless, while we are excited that we are able to kill many of the cells, and it's visible, just like every other therapy that we are seeing, cancer cells, just like humans, are constantly evolving because the cancer is trying to survive in the hazardous body that you are now basically treating and doing various different things. And what we are finding is that cancer cells are able to also cheat that virus, where it doesn't die and it stays as a persistently infected cell. And if it's not treated well, and if you don't remove it, it's like a ticking bomb that ultimately can then become another resistant cancer over a period of time. And for those of you working in cancer biology, or those even working in microbiology, are beginning to understand that diseases that we thought were very simple, targetable disease, that if I can find that one solution, I'm definitely going to solve the problem. Understand that tumor heterogeneity, microbial heterogeneity is extremely an important part of this. Under the microscope, the cells look very similar. But when you actually do the molecular profiling, you will understand that the tumor behavior is changing because the tumor cells are also changing because the genetic makeup is changing. There are also subpopulations within the cells that we call cancer stem cells that are in there maintaining that cancer. And so one of the things that my team is actually working on is how can we understand what is the genetic rationale for this cancer stem cells existence. And work by my PhD, ex-PhD student and postgraduate, Dr. Archana, is exactly that. Growing the cells, treating them with the viruses, and if they survive, keeping them, and understanding how can we, for example, kill them, or why do they become resistant? And really trying to clarify the genetic mechanisms of that. We don't have the answer, but that's the kind of thing that I hope we can think about, because these are potentially lower cost solutions that could be relevant in our part of the world. And so one of the future perspectives that we talk about in cancer research is how do we deal with heterogeneity? And today, we have single-cell technologies, and I'm quite happy that at Sunway, we have invested significantly in single-cell transcriptomics and genomics, and we welcome collaborators to actually work with us. But equally important is to ask ourselves, why is it too late? Did you know that despite the genetic advances, the single most efficient way in which we can reduce the burden of cancer today is by just having more effective anti-smoking campaigns? Any one of you smoking here? I'm so happy I've not seen anyone smoking at REC thus far over the last 3 days. Just make sure you don't go out of the gate and smoke, all right? Just remember that you are a mutation ticking bomb. But the idea here is, look at those cancers. It takes anything between 10 years to 25 years to even 50 years for it to actually evolve. Another important thing, and I think REC is also a great place because hopefully the computer scientists and the engineers can actually work together with the biomedical scientists and doctors. Because remember the story on AIMP3? Everyone would have said, why are you wasting time on that gene? The textbook says the gene works like this. But today we know that AI can actually source out various different things and come out with hypotheses that we would never have been able to. But it's your job then to test this hypothesis and see whether it actually works. And finally, my talk is now going to shift towards destiny from DNA. I think one of us, all of us, right, come to a university like REC or Sunway. We may be so many thousand kilometers apart, but we are connected by our Tamil Hollywood and cinema and pop culture. And tonight, I know my wife is excited. There's a Maniratnam concert here. No, not Maniratnam, A.R. Rahman concert tonight. But beyond that, all of us are human beings. All of us have shared humanities. We also understand that the biggest problems out there is not our genes. It's not even the infrastructure that we have. You have everything here. But it's really our failure to understand what are the socio-economic and also various echo chambers that exist outside of you. The COVID-19 taught us that just knowing what COVID was, coming out with a vaccine was not enough. We needed to be able to convince people to take it. Behavioral modification, lifestyle choices, getting industry to invest, getting policymakers to do things so that they can actually ensure that your science gets translated takes a lot of things. And more importantly, you'll find that, oh, my slides are not moving. Can someone help me? I just realized this. It's stalled over there. It's not a video. No, it's just not. It's frozen. But anyway, I'll just continue while the tech team gets their act together. But let me just get this up and running. With COVID-19, it taught us that basically all the issues are connected. Healthcare, equity, misinformation, climate change, they all have got various different determinants, right? They're all connected. And really, when we think about really finding solutions, we got to work at a systems level. Thank you so much. Yeah. We also live in a world where everyone is an expert, right? even if they don't know what they're talking about. I always talk about this whenever I go for weddings. And people tell me, oh, you work in cancer. You know, the only thing you need to do with cancer is just eat turmeric. And then I say, well, if that is the case, why do Indians have cancer? We eat curry every day, right? And so it's really important to understand the world that we live in today, where everybody is an expert, but everybody also knows that they don't really have the answer. And this is what we call a post-normal world. A post-normal world where you are also very uncertain. What we thought for sure we're going to have this in the future is no longer so sure. And this creates anxiety. You probably wonder, oh yeah, we managed to run away from COVID, but why am I still so scared? And that's because the post-normal world is complex, it's chaotic, and it's contradictory. And this is where all of you need to think about your role as citizens, but also your role as future scientists and innovators. You cannot believe that your innovations is going to just speak for itself. Data will speak, and I shall not say anything. Trust me, no one's going to listen, right? You have to make an effort to bridge both policy and public. And that is because when you look at the policy interface, it's extremely messy. Preparing a proposal is not the end. It's just the start of maybe the end. And you have to work with different people to bridge the knowledge, to ask what is it that they know, what is it that they don't know, and try and build that trust with the society and the people, building your influence. How many of you have LinkedIn profiles or Instagram profiles? How many of you? Raise your hands. Okay, very good. How many of you update about the amazing work you do in your institutions? Okay, not so many. Guys, one of the things you should do is really talk about your work. How do you expect people to talk about the amazing things you do at REC if even you don't talk about it? All right? These last 3 days, I have been so overwhelmed because what you have done at Titanium REC, I have not seen this anywhere around the world. Please give you all a huge round of applause. It's extremely important that you actually talk about the good things you do because this is the world we live in today. If you don't tell, nobody's going to tell. And this is where we transition to the importance of finding the purpose. When a world that is complex, chaotic, and contradictory, what all of us need is a very clear idea of what our proficiency is. What am I good at? I was so amazed by your ideas lab and those kids that were presenting those ideas because not only they were good at what they did, they had the passion. But passion sometimes alone is not enough. You know why? Because sometimes you can give up if it's purely passion. But passion with then purpose, right? Look at Abe sir. He just arrived last night, but he still came here today because he knows why this organization exists and will be here for the generations to come. And so each one of us have made the right thing. We are in an institution, a university. We learn things that we didn't even know, we don't know, that you don't know, that you don't even know, you don't know. The unknown unknowns, right? And that's what you do every day. Your lecturers teach you, you go there, oh wow, and all right, you learn. You become aware. But besides knowledge, you also build skills. But skills are not just experimental skills. I can tell you, I came back from Cambridge and thinking I am the world's expert in this technique. But within 5 years, the technique became obsolete. And so the only thing that you can actually build upon is actually the ability to learn, the ability to connect, the ability to do things and create solutions. And that's why the smart skills, the ability to connect your brain with your heart, is equally as important as your hand skills. And that's why at Sunway, we have something called Sustain, and I have a video here. And one thing that I want to work closely with all of you, because I think one thing that we can all do better is to think about how does ecosystems like REC, Sunway, also act as a living laboratory to be more sustainable. As you know, we have a lot of waste. And part of that waste are the microplastics that are going to be the next big thing like smoking that is now going to be found to be causing all the different diseases that are actually out there. So how do you actually create that? And I've got a short video that I'll play. Is there? You know what? Because of the interest of time, maybe we'll play anyway.
Imagining sustainability education for people and the planet. We aim to nurture ethical, empathetic, and future-ready leaders empowered with entrepreneurial thinking, integrity, and lifelong learning to solve global challenges. SUSTAIN stands for Sunway University's sustainability-focused, transformative, accessible, immersive, and networked learning embedded across all undergraduate programs through 3 SDG-aligned core courses. Sustainability is core to every Sunway student's journey. Through 3 compulsory courses on integrity, community service, and entrepreneurship, students move from values to action. Rooted in the UN Sustainable Development Goals, this pathway builds future-ready, sustainability-literate graduates. At Sunway, innovation isn't just what we teach, it's how we teach. From our Paradox of Theron online game to high-flex ethical case studies and fieldwork with communities, students learn through immersive, scalable experiences that turn values into action. Our flagship course, Planetary Health and Sustainability in the Tropics, brings students into rainforests and cities to co-create sustainability solutions, drawing learners from Harvard, Oxford, Lancaster University, and beyond. The impact is clear. 98.5% show enhanced problem solving. Students co-develop sustainable solutions in urban communities, and many alumni are now leading in ESG and sustainability sectors. These results are not just numbers, they signal a lasting mindset shift. We've embedded sustainability into every student journey, fusing real-world engagement, immersive learning, and global collaboration. At Sunway University, we're not just reimagining education. We're living it, and we're ready to lead the change.
Thank you. Well, the next time we will make sure that we put REC there as well, next to Harvard and Oxford. So guys, ultimately, we are in institutions that are pretty amazing, right? Because in the end, it's our own imagination and our own hard work that's going to limit us. And so one of the things that I want you to think about is, what can you do as an individual? You know you have the right DNA. You have come to an institution. You are already a university student or going to be a university student. An important thing is to realize that we are no longer a victim. We have the ability to design our future and not leave anything by chance. That you as an individual can make a difference. You had a glimpse about Sunway, that building and what have you, but 40 years ago, it was actually a wasteland. A complete wasteland with no trees, with nothing. But one man imagined that it can actually transform into a completely green, sustainable city with 250,000 people living with 42 million. And his goal is to be the best. You got to learn, work, and collaborate with the best. The idea is, just like a cancer cell, when a cancer cell becomes too good, and beats human, what happens to it? The human dies, the cancer also dies. The only way you can actually exist is learning how to not kill off all the resources you have, but actually coexist and co-prosper. So I have a couple of things that I want to share with you that I use every single day in my life in terms of how I find passion. The first thing is to seize opportunities. Because you have a lot of opportunities. Yesterday, amazing robo-wars. Some people won, they took part, they participated. You have great MCs. But why do these people get the opportunity? It's because they say yes and then fear later. I always say, I'm not the best looking person, I'm not the fittest, I'm not the smartest, but I'm usually the first one that says, yes, let's do it. And when I think about the opportunities that I've had in life, it is all about stopping us. What stops us is usually fear, right? And I don't know whether you follow K-pop Demon Hunters. Okay, I see a few people excited here, but in Malaysia, it's pretty big. In the K-pop Demon Hunters, we are always stopping ourselves, the inner demons. That's actually us. Because we compare with people without understanding that success is not on your left. Success is like on your right. Basically, there are a lot of failures that continue to shape where you go next. And that is why I want all of you to really think about who you should compete. And I always say, compete today with who you were yesterday so that you are better tomorrow. And that's really like genes, because genes behave differently in new contexts, and humans also have different contexts. And I always use this particular study, although some bits of that study hasn't been reproducible, but what's exciting is our body can actually change the way in which we think, and our mind can then change our behavior, and when our behavior changes, we can also change our outcomes. Look at this guy. Do you think he's a confident guy? Yes. Why do you think he's confident? Because he's wearing his underwear outside? Yeah, I guess that has to take a lot of confidence. But it's that stand, right? Hey, look at me, I'm confident. And then Wonder Woman too. Yes, look at me, I'm also that. But nothing as confident as our Rajnikant, right? And that's power posing. When you look at him, he's just like a normal uncle, or maybe I shouldn't say that. But he is so confident. That's S. The next is empathy. All of us spend too much time saying, I want this, I want that, you hear me, and whatever it is. But empathy is one of the biggest superpowers that you can think about. The ability to see with the eyes of another, the ability to hear with the ears of another, and the ability to feel with the heart of another. It's not what you say that matters, it's what other people hear. It's also not what you want to achieve, but actually what they need, because they are the one that's going to buy their product from you. The other is to use as much resources that you have, and even when you fail, believe that you can grow. Because you must ask yourself, what value do you bring to society? What value do you bring to industry? And not how much your industry pays for you. Because while REC and Sunway University prepares you for potentially good employability and good income, your goal of education should be more than getting a better job. It's what can you do to make a better world so that other people like you can also have that opportunity. And that's the impact that you create. For all of you working in healthcare, you do not have to worry about what is my future. There are going to be more infections. Diseases that we thought that were already gone are going to come back. Unfortunately, we don't do enough exercise. And every 2 hours while I'm in RSD, they're always asking me, sir, would you like to have snacks? Right? Because basically our culture of eating, as my doctor says, causes me, my problem is not undernutrition, but overnutrition. So basically cancer, cardiovascular diseases, but we also know mental health is a big problem that's out there. And more importantly, planetary health and zoonotics. Collaboration and communication equally important. These are some pictures of me. I wasn't a boring academic. As a student, just like all of you, you must make friends. Look at your left and right. This could be your future networks that you create. But also, as I talked about earlier, your science only gets shared if you share. And you have to make the effort to go out there and be unafraid if people criticize, and you have to drive it. And I always like to show this because I make my wife jealous and say, hey, at least Angelina Jolie and I appeared on the newspaper, in one page, although she didn't really have a choice for that. So guys, the penultimate thing is I want you to stand out, because this is a world that we live in where perception and reality is almost the same thing. And you have to make your own effort to stand out, whether it's in the digital world or in the physical world. And finally, of course, you've got to make sure that you are doing well by doing good. There's no compromise on ethics. And when you put all of that together, we call it service. Servicing not yourself, but for something greater. 5-star, but with a heart. Because you are not only proficient, you're not only passionate, you've actually found a passion. So I'm going to end, I hope, with a power pose with all of you. Can all of you comply and stand up, please? Let's do this. Whether you believe it or not, let's go, yeah, we are all part of titanium. I've been energized with all of you. Let's do this. All right. As soon as you stand up and you close your eyes, I want you to also close your mouth. Okay? Let's do this. 1, 2, 3. All right. Close your eyes. All right. And then I want you to put your chest out. Think about a superhero. Think about whether you are an Ajit fan or a Mohanlal fan or, Soundarya or Nayantara, whoever. Sorry, I'm terrible with the names. Yeah. Now I want you to think, or you all want to be like Abe sir, all right? All right, think about it. Now, just quietly as you think about the one thing you want to achieve here at REC or in your life, that one thing. And how much hard work you have actually done to get you to where you are, but the goals of how you want to live up to your parents' aspirations, how you want to create a better future for you, your family, and the world, how you're going to find the cure of diseases or help people who have no access to healthcare. Think about that amazing opportunity you have with knowledge, with passion, with purpose, and proficiency. And in 3, I want you to power pose. Put your hands on your hip and feel really proud, legs apart, like Superman, Wonder Woman, what have you. 1, 2, 3, super pose. And now follow me. I am fabulous. Guys, you can do this better. I heard you yesterday at Robo Wars. You can shout. I am fabulous. And I am proud of who I am. And the journey that I've taken to be here. I am proficient. I am passionate. I have a purpose. I will discover the best version of myself. I believe in my voice. I'm strong as titanium. And together, we can make an impact. Yeah! Fabulous, guys. Thank you very much.
We sincerely thank Professor Veera Kumar Sivam for sharing his expertise and perspectives with us today. His session has enriched our understanding how cancer genetics and molecular biology can drive meaningful impact in society and healthcare. I now request our esteemed Vice Chairman, Mr. Abhay Meghanathan, to present the memento to Professor Abhimanyu Veerakumar Shivam.
Moving on to a very important part of the day. Rajalakshmi Engineering College has consistently strengthened its global footprint by signing MOUs with several leading universities, fostering collaboration, research, and academic excellence. Today, adding to this proud legacy, we are honored to formalize